start our last shot. For this shot is a close-up shot. I decided to go with the nose of the boat, like the bow of the boat hitting the water. And as before, we're going to recycle a few assets, but for this shot, we're also going to use some other techniques, and especially some new things, some new tools available since Houdini 19.5 that we're going to use, like some top level flip tools to get like a high res sim based on the previous sim, and it's going to be very much based on the camera perspective, because as we dive closer to the boat, we need to optimize a lot the area for simulations, because now we need a lot of resolution, because every, like, if the particles are too big, they start to get blobby and they throw away the realism of the scene. Be very mindful when you decide the camera that you're going to use. I have this camera. This is the camera that I have. The animation of the boat is not this one. I'm going to also like do another animation for the boat, but that's more or less like the type of shot that I want to get, like something like that, with the water here and the boat hitting the water and so on. So for that, we need to animate the boat. And what I'm going to do, just to explain you the steps, I'm going to grab the simulation that we have. Let me just place in manual. I also saved the scene. I got our mid shot, the shot 1 that we did, and I resaved it. So it's not based on the open shot, it's based on the first shot that we worked on, the one that's more complete. And if you go to the main wave sim, before we actually distort based on the big ocean, let's double check. Yeah. So we have this, right? And my idea, because we don't need the big waves now, because the shot's going to be so much close to the boat that we don't even know if we are in a very big wave or not. What we care is about the splash and the interaction with the flip. So what I'm going to do, I'm going to use this simulation, and I'm going to up-res this simulation. So we can basically use this before we made like the spectrum deformation on it, before we added like the huge waves like this. You see, like imagine that we have this, and looking from here, can you tell like if that's the big wave or not? Like it's hard to tell you. It's not like it doesn't matter for us, so we don't need that. What we need is to use this. We're going to animate the boat based on this one, and then we're going to work on the press, right? So for that, we can just get this one, and just to have a little bit more fun, we can just add some color to it. It's much more fun. Oh, okay, yeah, I remember. I don't have like the attribute transfer, so yeah, no color, it's fine. We can work on that one. All right, so let me go to the boat, and it's after that we start cleaning up things, right? Like, but for now, we can just go to the boat, and I already have an animation here that I did. I show you. It's nothing very fancy. We still keep the mirror, all right? I'm going to animate the boat here. Everything that was going out from this one, I'm going to transfer to be out from this one. And of course, we're also going to work on the sails later and everything. We're going to probably simulate just the Genoa. We don't need to simulate that because that's going to be out of our camera view. I'm going to focus more on this interaction of the boat here, and of course the deck, the splashes, and all that. So you can keep the trail. The trail is just to compute the velocities. And let me show what animation I have here. So this is the new animation that I have in here. You see, I have a lot of keyframes, but basically I want to render from the frame 90 to 168. But you can just have an idea of what the boat is doing here, right? Because in this case we have like the boat splash and all, right? You can use like the low res sim for that also, but this will work fine because in this one is already distorted by the boat, but we have an idea of where the waves are to animate it. So you come here and then the boat goes and do like goes up in the air like that, you know, like after the wave. And let's see from the camera view, you see, and it's going to splash down this nose on the water. And let me go here. Yeah, it's going to hit the water, it's going to splash around, and that's basically it. We're going to have like this moment where it just moves, and yeah, and it goes like that. So we're not going to use the high sim for that, we're going to use the other one, and basically that's how we're going to start working on that. So let me create a node for us to do all the new sim on it, and then we can later we can just let me just move these guys away. The reason why I'm keeping those, like I think these two we can just delete. This one I'm going to keep for now because we might want to use something from that, and this we don't need. The rain, yeah, we will reuse the rain. So I'm going to just create an upres. Let me do like a geonode, and let's call this guy, let me color this, and let me call this guy upres sim, right? Upres sim. Just yeah, think a lot about your camera beforehand, and because everything is going to be pretty much based on that. So yeah, we need to be very mindful about it. Let me dive inside. The first thing, I want to have like a box, that this box is going to be our bound area that we're going to optimize based on the camera. So don't need to be very precise, but at least some degree just for optimization. And let me give you the numbers that I have here. So I have like, let me copy here. Let me see if they paste values. No. Okay. So 17 in here, 6.9. Oh, 6.9 and 15 and 8.75, 1.5 and 0.63. Okay, so this is the position more or less of my bound. There is no animation on this. So what I'm going to do, I'm going to put a lot of points inside this. So I'm going to use the points from volume. What I'm doing here, I'm creating a dynamic bound that is basically cut by this camera. So it's going to be very optimized based on the camera angle, and this is going to be a dynamic bound, and it's really, really powerful. That for it allow us to have a very high res sim, you know, like, so that's really great. I'm going to use like 0.8 for this one. We don't need a lot. We're going to mesh this just to create a bound, because it's easier to kill the points based on the camera than the mesh, because the mesh you need a lot of resolution. So what I'm going to do now is to create a volume from the camera. So remember that we did this before. I'm going to call this density. It's a scalar, and I'm going to set this to 1, 1, and 1. And this is from camera, so we need to grab our camera. So that's how it starts to be very linked to the camera animation. So don't try to run everything and then say, oh, okay, my camera didn't work. If you're using mine, okay. If you're using yours, just do some play blasts, some flip books, just to double check if the boat's moving with the camera, everything's look good. Then you commit to everything else, right? So I'm going to get like just 30 meters from the camera, and I'm going to increase this a little bit, like here's the bound. I'm going to also increase the resolution so we can see. This is the camera perspective, so this is the area that camera is covering. I want to increase that a little bit, so I'm going to do like minus 0.2 here, 1.2, so it's increasing, and then in here minus 0.2, and here 1.2. Okay, so now we have a little bit of room, like we don't want to kill exactly where the camera stops, we need at least a little bit more room. So let's convert VGB convert. VGB convert VGB. And what we want to convert, this is a fog VGB, right? Like, so I want to get to the VGB, and I want to convert this from fog to SDF. And that's going to give us like a volume, a sign distance field volume, and we can kill the points based on that. What we're going to do like a compare, a point VOP, and we can do this. You can say kill cam based, and then we can bring a volume sample. We're going to sample the volume from the input 2. We need the position of that, and we need to compare. And for the compare, what we want is everything that is bigger than 0. If you remember what we talked about, inside the volume is negative, on the surface is 0, and outside is positive value. So everything that is positive, it's outside that volume, I want to kill. So I'm going to do a CG remove points, the HDA, and I'm going to delete. So we end up with that. That's really good. What we need now is to create attribute. We need some p scale, so attribute create. We need the p scale to be able to do a VGB from that. The VGBs are going to look into the p scale to define the area. P scale. So yeah, and it doesn't need to be high resolution. There is all this part here. There is nothing to do with the actual resolution of the simulation that we're going to do. This is just to create the area, the bounds for it, like read the data when simulating. Like it's not going to care in the areas that are outside here. And if we do like on the camera based, it's much more efficient for the area. Okay, you might ask me why we didn't go like that for the big ones, because the big ones, you actually like have a huge seam, and you could do that, but it's different, like you have the horizon, you have a lot of things, and in this one you're looking down, you actually just look into this area. And in the other one, we might wanted like a little bit of bleeding outside to merge with different simulations and so forth. Like, so let's do a VGB from particle. And also I thought was important to get the key concepts of flip simulation doing the traditional way, without the new nodes of 19.5, because sometimes you work in the studios, and some studios they don't change for new releases of Houdini out of like because the project's already running, and you don't want to have like different issues because you updated your software, like, so they tend to keep using like previous version for a long time. Some versions that are really solid, that they already have like its own plugin for that version, so that's also important. Like, so let me do a VDB from, I'm very talkative, right? Like I'm talking a lot. I'm going much beyond just the class, sorry. Okay, so we can keep like as one, like it's all good. We just need this rough surface, you know, and we need you to convert VGB again to polygons. And this can be very low res, so you can crank the adaptivity a lot to have like something, yeah, you don't need a lot of resolution for that. All right, so now I think it's good for this class. We're going to start bringing in some flip. You have like all these new flip nodes in this, that even the solver, you can do everything just on this level. And we're going to cover that next, starting on the next lesson. Thank you. Let's start working with our flips using the new nodes from Houdini 19.5. We can disable this. For now was just to use the surface was just for animation, but now let's dive inside. And when you do like a flip, you have like these options of the configure. The configure is going to place a few nodes already for us in sequence. So what we need is the configure wave tank. And you see it's all this combination. We're not going to use these guys. So I'm going to just set them apart because I might show you something later just for you to know, but it's not what we need to do. So what we need is this sequence and a few more. So this input is the one that was using by this spectrum. So let me just grab here just to see the default what's happening here. And let me go around 48. Just the reason why it's 48, we don't need a lot of pre-roll for that because we are already going to start based on the flip simulation that we had before. So it's just all right to have like less pre-roll. I'm going to enable this. And this is going to give us like this. That what is this? This is this box, this bounding box. And it has like this ocean spectrum. That's just a random one. And it's just using that to displace this. So first let me come to the visualization and point as spheres. Let's disable that. I don't know why you would like to see those. So yeah, this is not what we're going to use, right? Like, so let me just disable this. Let me place this aside and let's do another thing. So first, what I want to do like a file. If you do have in your scene the low res compress that we had, remember on the shot 2, the first shot that we worked, we first have like a very low res sim for animating the boat. So that is the best thing that you can use here. If you use a higher res, the problem with the higher res is that already contain the splashes of the boat. And we want just like the regular flip without the splashes. So that's why it's good to use this one. This is the path that I saved mine. So it's the low res compress. Yeah, it's this one. And you don't need to unpack this. It's going to read from here. So now I'm going to have like this simulation and it's running in here, right? Like so. And if I plug the bound that we created from the camera, look how amazing. Now we have like something that really matches exactly the area. And now I can come in here and reduce the particle size to like 0.5. I'm going to go even higher, but you see how compact. And this was very low res and I can come in here and do like, for example, 2.5 and see how fast, and it's very optimized. And if I look from the camera perspective, it's all covered and with like some room outside that also. Great, we're going to change that later. We're going to increase the grid scale, decrease the grid scale to get a little bit more attributes resolution. And also, so we keep everything as is, but in the attributes, we want to enable the ID and the vorticity. You can enable that. And we need the collision. At this stage, we don't have any collision. So let me go back here. Let me visualize this guy. And let's place a flip collide. Collide is this guy. This is also very smart node. If you dive inside, there's a lot of things going on, and what it allows us to do is just to bring a geometry, and it's going to convert to VDB and optimize that and so forth. So it's really good. I'm going to do an object merge. What we need is just the boat collisions. So I'm going to dive into the sailboat. We don't need the distorted collision boat that we did. It's just the regular one. So it's just the regular from the animation that we did. Trailing, blast. So we just kept like this part, and that's what we need. So I'm going to copy, come back, and paste it in here, and drag this guy here. You plug the geo here, and it's going to do a lot of things for us. We don't even need the trail node, because it calculates the velocities inside. So the velocity scale, I think all we do need. I'm not sure if there is a trail node inside, but we have done that before. So it's in, as we mentioned, we have velocities on it because we use the trail node in here. So we calculate the velocities. So it's all good. But I want to increase that to 1.5. The reason why I want more dynamic splashes, it's going to be a close-up camera. I want to have a lot of things going on. So yeah. Anything else, it's all good. You don't need any other thing in here. And if I tell you that it's almost it, would you believe me? So yeah, it's almost there. But then if we dive in the solver itself, let's go just to see the basic thing. So you have the start frame that we already changed for 48. The general, the time scale, the substeps is the same thing that you can control in the other thing. Actually, there is a flip solver inside this guy, and what it's allowing it is just like link these values to the flip solver or to other nodes that control the flip simulation, but most of them you are already familiar. It's all like just allowing us to have like simplified user interface. So the waterline is okay. We don't need to play with that. We can keep as is. Collision, the same thing is the collision tab of the flip solver. We're going to keep as is. We actually don't need to change anything here. With the flip behavior, we do need. The thing is that how they transfer the velocity. And there is two methods. The one method is the epic swirly. And if you read here, it's just telling that this is more for smaller fluids that had like a very dynamic movement. But for bigger scale splashes like oceans and rivers, the flip splash is more suited for that, because it allows to have like a surface that contains all the deformation on it. All right. So yeah, everything else is the same. We don't need to play with that. It's good. And yeah, that's all good. So if you double click here without opening it, that's tricky, because if you are curious to look inside, you might want to come in here and say allow edition of contents. You double click and you are actually looking inside the node. And here is where I mentioned that we have like a regular flip solver, like this guy. And if I dive inside this one, you're going to see there's a lot of things. Some of them are not, you have like switches to say, I want that or I don't want that. But basically, you have here the flips over, and that's where those things are linked. So when we change there, you actually change inside the flips over as we did in other classes. So this is the regular method, okay? And then you have all these forces. But then how can you add forces? You could dive inside and do the same thing that we did, but I want to show you how you do in Houdini 19 using these nodes. I'm going to match current definition. If you double click now with that locker on without opening it, it goes to this area. And what this offers is to add sources like with pop forces, with pop forces, or any volume type of forces. So let's do like a point drag, the thing that we did before. Point drag, pop drag, actually, sorry. And we're going to just plug this in here. And let me disable this so it doesn't keep computing all the time. And I want to have like a very tiny drag, like 0, 1. And we can just set like a random ID that we created just to give a little bit of variation. And the resist, yeah, it's all set for us. That's good. So the next thing, I want to do a mask based on the vorticity. So let's do a geometry mask, geometry pop, sorry. And let's call this vort mask. And let's dive inside. And let's fit range our vorticity. So bind vorticity, it's a float, and we're going to fit range. Vorticity goes very high normally, so we can just have like everything that is less than 25, I don't care, I want 0. And everything that is above 60, I want full 1. So it's going to have like a gradient from 25, that's going to be black, no vorticity. 65 is going to have, 60 is going to have full vorticity, and everything above this is going to also have full vorticity. And let's bind export this mask, bind export. And let's say, let's call this vort mask. It's a name that I just decided to name. I'm going to copy that so we don't make. Okay, so we created a mask. The mask is going to allow us to do things with things that has high vorticity. And what I want to do that, I want to just make them fly with the wind. You know, I want to bring the wind. So everything that's going to splash and have high vorticity, I want the wind to take it away. So let me do, we can do like a pop force, or no, let's do like a pop advect by volumes. And we have our wind attribute, remember? So let's use that. We created that fancy wind attribute, so out wind force. Okay, so this is what we need. It's val. We want to update the force but not treat as wind, and we can increase that a little bit. So now we have like a wind that's going to be applied to the high vorticity areas of this. But for that, now it's applying to everything, but we created this mask. So I want to use a Vex expression, and you can do the pass-through just to get like the force scale is the first one. We can delete everything in here. So I want to multiply that by at vortimask, and let me disable that. Okay, so I'm multiplying the force scale, this number, by 0 to 1. So everything that has not a lot of vorticity is going to not be influenced by this wind. Everything that has a 60 or more is going to have full influence of the wind. And that's it. We have set forces inside our solver, so that's how you do it. If you want to do other type of things, you can just add that in here. And here's the regular fluid compress. You can just set and then you cache. To cache, we use the same thing, so let's call this guy, paste this guy in here, and let me select, and this is $cache 2 in my case. And you don't need the full range, you need this to go from 48. I want to go all the way to 164. It's also optimizing that. And in here, the final resolution that I'm using, but you need to again figure out what works for you. But you for sure you can go. The idea here is to go much higher res than you would go do in your regular sim, because very optimized, the area, the bounds are very small. So crank that up as maximum as you can for this one. I go like with 15015 and also here 1.7. You can go even higher on this one, but or less depending on the machine, but higher than your final resolution that you had in your main shot. Okay, that's good. So that's all about it. You cache, and after that we keep working. We're going to process, we're going to mesh it, and then after that we're going to work in the Whitewater and so forth. So thank you and see you in the next one. Hey, so I got a really cool sim, and look how cool is the shape of that. That is consistently based on the camera. So we have a lot of detailing, and look this amount of details here. The very much smaller particle size. This looks strange, but it's because of the camera culling, and it's all good because if you look through the camera, awesome. So we have like this, and let's pick a different frame. For example, this frame. You see, look, the wave breaking there, and all this very like this splash, very detailed, very dense. And let's go a little bit further like this, and let's see. Yeah, look, it's really good, really great. So much cool details, amazing. So you see, like even like the way that the water slide here and in this area looks really nice. The water is a bit floaty because of the VDB size, but we're going to work on that. So let's start. I want to start meshing this. So to start meshing, let's first do unpack points. I want to set the P scale based on the velocities. We could do that based on vortices, but I want like the particles that are shooting fast. I want to have like a smaller P scale. So let's do that. P scale. No, sorry, it's not. It's a point VOP. Would be good to say like a P scale based on whatever, and then it goes. Okay, so P scale by V. Let's dive inside and let me work on that. So I'm going to get the length of V, and let's fit range. And let's visualize also on the color. But I want from 2 meters per second to 6. And so everything that is lower than 2 is going to have the same P scale. And so 1. And everything that's 6 is going to decrease all the way to 0.2. So 20%. And let's visualize that on the color. Okay, so something is definitely weird in here. I think it's because we have like that. Okay, there you go. Awesome. You see all this, it's going to decrease the P scale. So for that, we're going to do the same thing. We're going to do a byte export. Let's call this guy P scale. And you can copy that and multiply. So we're going to multiply our P scale by this new range, and these parts that are looking like black, that is faster, they're going to be 20% of the original P scale, right? So yeah, let's visualize the like lead spheres, and you see the lead sphere is another way. I don't know if I covered that, but basically is another way to look to the particle size. Before we use disks, but the disk is much more hard on your system and your viewport. So the lead spheres, they work really fast. It's really good to visualize that. So you see the size of the P scale, and that's going to reflect on our mesh, right? So I'm going to disable that, and let's go back to flip. We go outside, and now we can do the regular VDB from particles. So let's do a VDB from particles. Yeah, not the fluid one. We're going to use the regular one. All right. So first I want to copy. We have like the particle. Yeah, it's disabled here. So it's here that we define. Okay, I'm going to copy this. Copy the particle here. And I'm going to paste that, paste relative reference in here. And then we'll multiply that by 0.4. I want to have a lot of detail, so it doesn't matter if it's going to be a little bit strange, the mesh, because it's going to lack a lot of points to make it smooth, but we don't want it smooth. It works for this type of shots, and it might take a little bit. No, it was really fast. So okay, so it basically, you see, like, because the particle scale is a little bit small, it doesn't connect and merge, so it's all blobby. But we're going to do a VDB smooth. But before, we don't want this very thin surface. We want to do the same trick as we did. So I'm going to blast our surface. So let me go in here. Let's surface, delete non-selected, VGB reshape, erode by, I don't know, like maybe 0.8 is enough, and we do a VGB combine. This guy, and we do an SDF union. So now it's going to look thicker like that. It's going to be easier for us to just delete and keep that, or if we render with everything, it's fine in this case, because we don't need the very thin surface on the top only. We can use the same. I'm going to cover that in the render time, but we're not going to clip. We're going to keep this whole thick mesh thing. Okay, now we can do the VDB smooth. Okay, VDB smooth SDF, and this one we're going to use the mean value, and we can keep it as default. So we're going to see that now it's going to make it like, yeah, now we get the surface. Nice, cool. Look, we got like all these nice details just because we use a smaller P scale. If I come back here, just to show you, and if I come back here and delete this or multiply this by 1, you're going to see that everything is going to become much smooth. And it's just using the regular P scale that is very small, but you see it's still blobby because it's very close up. And look, this is not nice at all. So if we do that, like 0.4, we gain all this cool detail. It's going to take a little bit longer, but it's not much because it's very optimized. And look how cool. And this part, the size of this splash and all that, look how it would be if we don't change the P scale. If we get the original P scale, have a look at these areas and these areas. You see, we get like all these blobby parts that look really strange. And you might ask, okay, but we lost all that. But yeah, but we need to lose that, because this is normally like particles, or it's very thin mesh, but definitely not like these blobby pieces, very big chunks of pieces that look like a droplet the size of an orange, you know. So it's not like that. So it's better to keep a smaller p scale, and you can use that. That's great. Okay, we're going to have splashes for all these other parts. All right, so with VDB smooth, and we can now convert this. So we can do a VDB convert VDB to polygons. We can do a slightly adaptivity just to make the mesh a little bit more manageable. It's very high res, so 0.005 going to help us, yeah, eliminate a little bit of the, especially in these areas that is just adding to the geometry. But look how nice is this mesh, how much details we have here. And that's what I mean, like from the camera, that you need to be very you must be very like assured by your camera, because if you want to change afterwards, it's not forgiving at all. You can't do anything else, you know, like any other angle, it won't work. So, but it's really great. And we need every time we VGB, we lost the all the attributes. So I want to have like back vorticity and velocity. So we're going to do an attribute transfer. So I want to transfer, let me grab here, and let's pick from this guy, and let me make it here and make it there. Okay, so this one, we want to bring the velocities and we want to bring the vorticity. Don't need to worry with the conditions, it's good. We could pick the geometry to get even more detail, like a very small peak. So peak, not soft, like just a regular peak. So the peak, it pushes the geometry into or out of the normals. So if you have like let's see this part, you see this area, if we do like minus 0.001, very tiny, it's just going to push everything towards its perpendicular to the normal of the mesh. So I don't notice that we have like any big difference. Let me go bigger here. Yeah, you see it start to shrink, but then we start to have these overlaps. So be mindful with that and just keep like a little bit. And if you do positive values, you're going to make the blobbier, like thicker in general. All right, so now I want to push it along the normals. We did that before. The reason why is because this area is very high, because the collision that we got for free here, it actually wasn't very optimized. So it's thicker. And also because we make our mesh thinner, because we played with the particles, the p scale, and the VGB reshape and everything that we smoothed out. So it was probably around here, not touching, but much better. But then we shrink, we did a lot of things, and now it's floating a little bit high, and the shadows can be a little bit distracting. So for that, what we're going to do, we're going to bring the boat again. So let me do an object merge. What we need here is the boat. I think we have the boat here, so I'm just going to copy it. Yeah, is this one? Just copy this. You could copy the whole node, but I already have placed this. Okay, I want to compute the normals again just to make sure. So normal, and I want to place that on points, and let's do another point VOP. All right, so first thing, I want to bring the normal itself. So let's do a PC open from the second input and the position. Now we do PC filter. We're going to filter the normals of that. So we want the normals. We want to normalize this. It means that the normals now, if we look to the n here, if I play that into the n, and if I go like and make like this bigger, like for example 1 and 5 and 5, it's just reaching 1 meter away to average the normals. But look the values of the normals. The normals goes from minus 0.05 to 0.97, like -1. So it's not like a normalized. So now I want to normalize that. And if you look, it goes from -1 to 1. So everything is more correct now in the range. We want to negate that. So because so let me show you the reason why we get in the normals, right? So the normals are pointing outside this, especially in this area. The normal of this surface is pointing perpendicular to this, upward. But I want to push the geometry downward. So I'm negating. The negate inverts that. So now we have the inverse normal for that. And if I would do a displace along normal, and if I grab the position, the original position, if I grab this normal that we just created, and I plug that into the position now, if I come to the amount, displacement amount, and like 0.14, you see it pushed everything all the way to here. It pushed down based on this normal of that. So yeah. So let me keep like that. We're not going to do like that because we need to filter. I only want to affect the area closer to the boat, so these areas, and we need to use the XYZ distance. We're going to grab from the second input and the position, fit range that to the range that we want to affect. So I want to affect basically, we can check that on the color, but I'm going to just like from 0.03, everything that's up to this distance has like full effect, and it's going to fade out to 10 centimeters away. It's going to fade out. So it's not like a very abrupt, and it's inverted that, right? Like, so we want to the inverse. So let me visualize that on the color, and you're going to see what areas that we're going to push is these areas. All right. So some of these on the top are not, but it's all right. We could just maybe increase that even more, like 15. Yeah, I think it's all right. We can affect all that. It's fine. It's going to give a better fade. And then this is the one that we want to apply. We want to multiply the amount. So we need a multiply. And we're going to multiply this one. This is going to be 0. So everything that we multiply by 0 is going to become 0. So we don't care about this. But now we need a control for that, because this is actually doing 1. And I want to promote this parameter. Let's call this mult. And this is now the amount that we want to push in. And it's not going to do anything because the mult by default is 0 in here. All right, so it's 0. We want this to be 0.02. And you're going to see that this is going to be pushed. Or not. Why? Let me just place this and do like that. Okay, yeah, it did push. Good. Yeah. I don't want to force too much because this might be actually falling into this, and I don't want to exaggerate. So if I would push like this, like to 5, it start to maybe stretching the geometry, and we're going to have like something of that, and it's not going to be visible with the motion blur and the fog, maybe just like that. Let's see how much we can push. Yeah, this start to stretch. So 25 is, I think it's a good amount. Great. Now we can cache this. So I'm going to do a file cache, and I have the name for that, and then regular thing. Thank you, and see you in the next one. Welcome back. So it cached much faster than the previous sim that we had. And yeah, we have like these nice splashes, much thinner. It's really nice in general. I was really happy with the result. Let's work on the Whitewater. So I'm just going to make like a time shift because this range is from 72 to 168, but we need some sort of geometry before that. I only cached that, so if we want to do something with the surface or whatever, I just want to do the time shift, and you have the clamp both, and I want to clamp from 72 168. What means is that after the frame 168, it's going to just freeze the mesh and keep like that. So we have, it's not going to complain that we don't have the geometry. It's just going to keep like that. The boat is going to keep moving, but it doesn't matter. This is our range. All right, so let's start working with our Whitewater. And I want to do 2 things. What happens sometimes when you have like something like that very close is that sometimes the mesh is here and it starts to show the mesh, but at the same time it looks strange because it's kind of poking through the Whitewater, and in general you'd have a very thick layer of Whitewater. So we're going to have the regular Whitewater, but we also want to have that at points based on the vorticity. So every area that's very high vorticity area, I'm going to have like a layer on top of Whitewater. That's going to help making everything more dynamic and blend better the Whitewater and the surface. So let's do that. We need to first define the vorticity. So we can do like a point VOP. And we can actually do like the visualizer, this one. Let me allow edging of contents and delete the unpacked. Let me place here. And let's visualize the color of that. So maybe this can be 20. Yeah. You see all these areas that are white, more or less, are the areas that I want to have like this layer of Whitewater on top. All this is going to help a lot, giving us a more blended look for the Whitewater. So I'm going to, now we have the color to be able to visualize the color. I'm going to come in here and let's say define vort, because we're going to define the range of vorticity that we want to affect. I'm going to go a little bit here, and I'm going to bind vorticity, and I want to fit range the vorticity between 16 and 25. The narrow selection. And if you visualize in color, I'm going to see like these areas I want to have Whitewater there. Okay, so we can bind export to a different attribute. I'm going to say vort select, so it's based on the vorticity. Let me go in here and say vort select. All right, so now I have this attribute, and we can do like a scatter, regular scatter. Scatter, and I want to scatter based on that attribute, so it's vort select. Yeah, you see we now have points only on the zeros, but of course we have like, I'm going to uncheck that, and I'm also going to uncheck the relaxed iteration. We don't want this very even, and I'm going to uncheck the maximum point. And let's crank that to 200,000 in my case, but start with less and see how much particles you have. We have a very dense area, but remember that now you have a lot of points, but we're going to delete all this, so we need to we're going to do that, and we're going to use the camera for that. So again, but we, instead of using the same camera that we have here, we're going to do a little bit different this time, because we don't need all this range. We're going to reduce basically that range for that, and I'm going to place this here because we're going to use it more times. I'm going to just do an output here. I'm going to just place a null and call this guy out q by cam. All right, so what I want to do here is decrease that, so we have a little bit more narrow, minus 0.1 and 1.1. Right, I also want to do this by size, and let's do like 0.5. We don't want a lot of revolution, and we can reduce that now. So this is the area that we want to delete. So now we can use that more often. I'm going to copy this and use like an object merge, just because I don't want these lines to keep crossing. And I'm going to bring this guy in here and do the regular. You can do like different things. For example, you could just do like a group and delete and so forth. Like that's an option. But I'm going to do the same thing that we did before. I'm going to use a point pop, and let's call like delete by cam. Select here, dive inside, volume sample, second input, compare, if it's greater than, I want to CG remove points. So if it's not inside that volume, I want to delete. And now we have all this, including this bottom that we don't want. So I can do another thing here. I can get like a get vector component, and based on the Y, we can delete this area because it's very defined. Let me just go ahead and disable this so it's faster to compute. Then we can compare. And if you want to see the height, you can just come in here and press space 4 in this, and it's going to give you this range. So we have now a range, and you see that this is around like -2. So I can say like everything like below -1.1. So I can say everything greater than or less than -1.1. Yeah, all this, it's bye-bye. So we're going to say or here, because if it's less than that and outside the camera, or outside the camera, I want to delete, not and, it's or. Doesn't matter which one. Okay, and now if I do that, we should have just the selection that we want. So we need to do a couple of things. I want to randomize the p-scale. So let's do an attribute randomize. and the attribute that we want to randomize, the p-scale. So p-scale, and I want one dimension, and from 0.008, 0.012, or maybe we can go less, right? Like, so maybe 7 and 1, something like that. Let's visualize that using the lit. They are still a little thick right there, so I'm going to go a little bit less, 0.95. Yeah, but remember that they are very much on the surface, so they're going to be more or less half of them are going to be underwater, so it's fine to have like that. And also we need like the density attribute because it's whitewater, so I'm going to just do attribute create. So attribute create, let's create density, set density, the attribute density. This is the default Houdini name, so it's not something that we come up with, so it's important to keep that, like V and density and p scale are like default. It's not in some other attributes we create because we can just bring the data. And I think, yeah, that's really good. So maybe in here, yeah, we can do some adjustments on the p scale afterwards, after this node, because then we can have more control over the particle's size after we start rendering. So I'm just going to place a file cache again here, and let's cache this out. And in the next lesson, we're going to work on the regular whitewater. Thank you. Okay, so let me place a null here, and let's say out whitewater from flip. So we know that this whitewater is just from the flip directly extracted on the surface. And because the vorticity, that is the attribute that we use, is also very dynamic and dies and just rises again in other areas, it's going to be really dynamic and it's going to look like whitewater. So it's a very nice way of also helping to blend the surface. Okay, so for now, what we need the compress attribute. So I'm going to just grab here, place like a null and say out compress. All right, so let me go in here and let me do like that, so we can keep our whitewater more in this zone. Yeah, I think it's good for us. So I can start making maybe a box for that, so we can say that so this is our compress, and let's place our regular whitewater source. So it's going to be pretty default, this one. So the first input is the liquid, that is our compress, the compressed fluid that we did. And then, all right, let's visualize that. Sometimes it's good to have like a volume visualization here, and you can place that, and we visualize the emit attribute, and you crank that to 10 so you can see more. And I'm also going to make this background dark and disable the grid so we can see here the whitewater emission. All right, so I'm going to crank the volume also, improve the like that, so I have more resolution on our volume. And let's start from the emission area. I'm going to get like 1.9 to 3.8, just reducing a little bit. When you reduce, you allow more whitewater. and I'm going to get like nothing from curvature, but something from acceleration, just a little bit. So when the particle shoots very fast, we're going to get like some white water, but mainly from vorticity. And this one I want to go like a lot, like the range goes like really a nice amount of white water. Also, you need to remember the same thing you can do like in stages. The same rule apply for that one. So, and that's basically it. I'm going to place a null and say out Whitewater emit. You can cache this. Let's see if it's necessary. To visualize the necessity, normally I just move a frame and see if it takes some time for it to happen. This is not most of the time, it's just because of calculating the sailboat, but not like if I come and do like this and reduce. VGB activate. No, yeah, it's okay. You can cache this out, but I'm just going to go straight into the DOP network, and let's create our Whitewater solver. For this one, we do need a little bit of pre-roll, not as much. I'm going to keep running from the frame 48 that we had before, that the same that we started our simulation for this area. So when this render frame starts, we already have some Whitewater going on. So it's good like that. So let me call this Whitewater sim. Keep the same standard. Let's do Whitewater object, Whitewater solver, no gravity, and we can probably grab our collision. No, yeah, we don't. we can grab, but not from there. Yeah, I think it's better than try to find it. Is just to place a static object and get our boat here. All right. So remember that now we did a new animation. So if you have like this boat collision VGB stored, you need to rename that and actually set like a close up and recache that. Okay, you need to recache this guy, right? Because the animation changed. So do that, and then you can import that inside. So I'm going to just copy this. Go in here, paste this. You can copy that. It's going to help you. It's use the form geometry, right? Like so. You can reevaluate that if you have like more sub-steps. It's okay, but I don't need any of these. I just want to go here to the volume sample and paste that in here, but I'm going to just change that to the VGB. Merge this and this. Yeah. All right. So same thing, pop drag. Drag. The drag I want to have like, let's give like some randomization like that. It's good. To the particle forces. And I want to create a group based on the spray. So remember, like we can do like a pop group. I'm going to, let me think. Group name. Let's call this spray group. Right? Let's enable that. And let's say that in group is spray is bigger than 0.15. And we're going to preserve the group. Every time a new frame comes, it's going to just add to the group and add to the group. So if it's flying, we're going to have this set to the group, and then we can do the same pop advect by volumes in here. We can bring our wind. Wind force, yeah. And we're going to do the same thing. We're going to keep like that. Yeah, I can keep one. I think it's fine. But we want to do that to our group here. So if the particle is flying, then we're going to get this to be affected by this wind. All right, so good. We need to kill, like, because otherwise we're going to keep adding a lot of particles in the areas that the camera doesn't see. So I want to, instead of deleting them afterwards, if we delete here, we save a lot of resources from the solver. So I want to delete that. So we need to copy this guy and dive inside, and let's create a geometry VOP. Let's say same thing, kill by cam, and the inputs. Oh, I don't know. No, it's on points. Geometry VOP. What we want to do is just grab like this and paste in here. So we're loading that volume in here, and you dive inside and do the same trick. Volume sample. So volume sample from the second input. No, the first input in this case, because the order of that input, it reflects this order. So it's different than outside, that the first input is ourselves. Here, the first input is whatever we place in here. So it's from the first input, grab the position, we compare. Now we want everything that's outside to be deleted. So if it's greater than 0, if it's outside our volume, we want to remove. That's very efficient, because then every time the particle goes a little bit away from the camera frame, it's going to be deleted. Let's now just do the final tweaks on our Whitewater. We need to bring the volume. So let me go in here and blast out surface, val, delete non selected. Let me press here. Let me call this out volumes. All right, so let's dive inside. So the volume, out volumes, emission, out Whitewater emit. Great. Do we need the bound? We can use, probably we can't use that. Yeah, we need to, because for that it actually needs to be a square. So we can just grab this bound and say like, let's place like a bound. Come to this guy. So this is grabbing the full area. That's great. We can just increase maybe the height, upper padding maybe 2 meters, just if the particles fly higher. And then we can just place like a null and call this outbound. Outbound. All right, so we need to link that in here. Let's do the same thing that we did. I'm going to come to this guy, limits, reference, scene data, object. This is the uppress sim. right, so let's go back to these parameters. The scale, I want to go like 0.1. Just make it a little bit bigger if you feel like your machine won't handle as much, and you can do more than one simulation again if you feel like you need. Okay, add state attributes, and in the emission tab I want to emit a little bit less this time, like, because just to have control. I think 0.2 is good. Velocity is okay, and particles can die pretty fast because they're going to be dragged out of the camera. Play with the seed. I don't want the bubbles, I don't care much of them for them. And some noise. I want to make this 0.35, 0.35, 0.35. Also, if you do want to create more than one simulation, just come to the offset and do something like that, just to change the noise from one to the other. 0.1, everything is the same. We keep forces. I think we can keep the regular forces, and foam, yeah, I can keep like that. Maybe a little bit more variable stiffness. We don't need to enable erosion. I want much smaller for these guys. I want to reduce a little bit the strength in here. Maybe 14. A little bit of noise even here, just to break up constantly, and we keep that as default. I'm going to disable that. It might crash depending on the resolution. Sometimes I prefer to just disable that, and we're good. So now let's do the DOP import, and so DOP import IO. At this point, I know that some of the things start to become very repetitive because we did this so many times. So I'm just going to go as fast as I can. Geometry. So can delete some attributes. So attributes delete. Okay, I want to delete this, and I think we can keep everything as is with all. And great. Let me call this. That's it. So let's cache this out, and after that we can start working on our boat splashes. The same thing that we did, but we're going to optimize for this shot angle. See you there.